Okay, good day, guys. So moving on to exercise number 1, right? So in the previous video, I just gave you an introduction, right, to how to configure FLUIDSIM and zeros, right? And then we also like wrote a simple code, right? So now we'll be doing some exercises, right? So now we'll be doing our exercise 1, right? So our exercise 1, right, it's like they're saying half liter cans are filled with wall or ceiling paint at a manual workstation, right? So they're saying the lids are pressed. Okay, let me just verify if I'm audible, right? Okay. So now they're saying the lids are pressed with a pneumatic press, right? And then they are saying the cans are inserted manually into the press, right? So this is the press, right? This is what a press looks like. And then after pressing the push button, the cylinder advances and then the lead is pressed, right? So the cylinder here advances to press the lead, right? And then when the push button is released, the cylinder remains in the advanced position, right? And then the cylinder will only retract if a stop push button eh, or a dominant braking signal is activated, right? And then they're saying the cans are removed manually, right? So here, instead of a single acting cylinder, right, I just want to fix this, right? So this is part of the parameters, right? So I want us to use a double acting cylinder, right? So now they're saying design a pneumatic system in which this system can be used, right? So now, as I said, like if you look at this, right? So they're saying the cylinder, what you call, is able to advance to the main position, right? And it's only retracted. It what retracts the cylinder? It's a stop push button, right? So which means here, sorry, here, if I can just stop this, right? So here we should use. They said we should use a double acting cylinder, right? So now we'll get our double acting cylinder here, right? And then from our double acting cylinder, right, you can control a what you call a double acting cylinder with a 3-2-way, right? So now you have to get like a what you call a 5-2-way, right? So there's this 5-2-way here, and then there's this one here, right? So now, like with regards to our 5-2-ways, right? With regards to our 5-2-ways, right? So now, if we look at our instructions, right, they're saying the cylinder advances, right, when the push button is pressed, right? But what causes the cylinder to retract? It's a stop push button, right? That cuts the power, right? So now they didn't say like it's being actuated by as a result of another signal, right? So now, which means we can't be using this 5-2-way, right? Which means we'll be using this 5-2-way, right? And then we connect it properly, right? So now, since we have our output labeled here, we're just gonna also label this as Q0, right? So now we have now when you design your PLC, you're able to start and stop, right? And then now we'll write a code, right? So if I can just stop this. If I can just stop this, right, and then delete, and then insert network, right? So now they said here, right, our process is started when a push button is pressed, right, which causes our cylinder to advance, right? So our start push button is I0 here, right? So our start push button is I0, right? So you want to insert I0 here. Our I0 here, right? Just make sure it's in uppercase, right? Which is gonna be used to trigger our Q0, right? Means this is our Q0 here, right? And then now we play this, right? Okay, so now, like when we press our start push button, to play advance, right? As they said here, right? They said like after pressing the push button, the cylinder is advanced, right? And then they say when you release that push button, the cylinder remains in the advanced position, which means like if I let go of the push button, the cylinder has to remain in the advanced position, right? And therefore, like now I have to latch the signal, right? So I latch the signal, right? So I have to latch that signal now, which is I'm gonna put my Q0 here, right? And then I'm gonna put my stop push button, right? So that, as I said, like they stated here, this is the only thing that resists the push button, right? So now here we're gonna put the I0 to be our dominant braking signal, I1, so to be our dominant braking signal, so it can cut the power going to Q0, right? So now if I log in with this, okay, so it's not a big I1, it, and then I log in, then I log in with download, right? And then I play. Now, so now if I press this push button, my cylinder advances, right? And it remains in the advanced position, right? Up until I cut the power brake signal, right? Which cuts the power going to the output, right? So that's how you do exercise number 1, right? And then now, mm, okay, too far. And then now, like, as I said, like, putting an emergency stop, like it's sort of like an international standard that you always have to do. Like for example, like if you like, I also want you to do like some like research like on your own, right? But I want you to look at CNC accidents, right? Like or like these accidents that are caused by like automation equipment, right? In a plant particularly, right? So now if you put your push button, right? So now if like let's say you have latched that signal here, let me maybe try and do it here, right? See if it's gonna. So now let's say, uh, let me just stop this, right? So I want you to see the cylinder as it advances, right? So let me get like a one-way flow. Okay, yeah. So I want the cylinder to advance slow, right? So I'm just gonna put this here. Like this is just for demonstrating to you like what's the push button. Oh, let's put this at 2%, right? So now if I play here, right, and then advance, right? So now like putting in like what you call an emergency stop, right? It makes sure that like so now like due to the spring load, right, the stop push button like pushes the cylinder backward, right? But like an emergency stop, like it will stop the cylinder where it's currently located at that point, right? So now if I can demonstrate to you, right, and mention, So you have to now insert an emergency stop, right? So this is what an emergency stop looks like, right? This one, right? So this is your emergency stop. Let's say we insert it to what you call to I3, right? Let's say I'm labeling it as EMG stop, right? Right. So now, since now I have put in a new input as I2, right? I also have to come to this side, right? Come to choruses, right? And now put in I2, right? So I2 is percentage sign IX 0 point. Oh yeah, it's at right 0.2 slash bool semicolon, and then this is my EMG stop, right? So now, since I've inserted a new input, I have to come back here and build again, right? And then reselect to build, right? And then now, like the emergency stop, like it basically works similarly to your stop push button, but as I said, like it stops the signal like at that point exactly, right? You don't let it advance or retract, right? So now, if I were to add my emergency stop I2 here, right? And then now let's log in and log in with download. So now, if I were to play, right? So now I press push button, my finger advances, right? When I it retracts like clock. So now if I right now, imagine stop, you can see like it stays open, right? And therefore, like making sure that the power is completely cut off, right? It doesn't like, let's say, for example, like in a plant, right? Let's say a product was stuck in front of a sensor, right? So now if you're using your what you call if you are using your like your stop push button to stop that, let's say your conveyor is running, right? Yeah, this is a perfect example. So let's say your conveyor is running, right? So if your conveyor is running, right, and then let's say there's sort of like an obstruction that's causing a sensor to be on, right? Which in turn, like for example, let's say it's causing your conveyor to stay on, right? So now let's say like you were pressing stop, right, to stop the conveyor, right? But as you press stop, right, the power is cut, right? But it doesn't negate or it doesn't like take away the fact that like there's something that's running the sensor, right? Which means your fusel will always what you call turn itself back on its like on its own, right? But imagine stop, like as you can see, stays open, right? So it completely has cut the power, right, going to Q0, right? Even if like I press this, it's open up until like I have to change it and close it, right? And then, but so like if you what you call like if you want to see like how these different kinds of patterns work, can come to the lab, right? And then I'll show you how they work, right? But anyway, right? So now, like when you are designing your what you call your system, right? This here, these inputs, right? Like preferably in this order, right? These are what you call the most fundamental or the most important inputs that you must have, right? So in your circuit, right? If you have your circuit, right? I expect to see 1, 2, and 3, right? And then, so yeah, this is what I expect, right? So I want you to have your always. This is something that you almost must have, right? Your start push button, your stop push button, your emergency stop, right? These inputs must always be there, right? And then as their connection that I've explained to them how they work, right? They need to be connected in series to this, right? Your input with your latched output, right? So that like they will, since they are normally closed in their initial state, they will allow power to flow to Q0, right? Up until a point where you need to cut the power, whereby you activate either one of them, right? Depending on the circumstances, right? So now that's your thing. That's access number one, right? So now will be, so yeah, as you said, so like this is not a like lot, this is not another like reason why you need to use the what you call image and stop in every circuit, or when you're designing a PLC, your system must always have an emergency stop, right? So now, like another thing that I want us to go through, right? We have what you call, we have sensors, right? Different kinds of sensors, right? I went through over these sensors, right? But in the context of this, right, we'll be only be sticking to the magnetic proximity sensor and the limit switch, right? So this and this, right? So I know for a fact that you are familiar with them now, right? And then now we'll be doing our exercise number 2, right? So exercise number 2, they are saying, right? They are saying like PLCs will be diverted from one conveyor to another by means of a divert, right? And then they are saying what you call the diverting gate. The diverting gate is advanced when the start push button is activated and when the cylinder is in the rotated end position to ensure that the boxes are properly diverted. Right. So if you look at this statement, that they particularly gave us like two conditions, right? Two conditions have to be met for the cylinder to advance, right? So the first one, right? It's the cylinder, like it has to be at the back end position and you have to press the start push button for the cylinder to advance. So now you have to make sure that those conditions are met before the cylinder advances, right? And then they are saying that diverting gate is returned to to its inert position where when a stop push button is activated or dominant braking signal, right? They could say that, right? So general conditions are saying the a limit switch, a double acting cylinder will be used, right? And then they're saying a limit switch will be used to detect the end positions. So important, right? So another statement that they're saying an emergency switch must be used to stop the system in the case of an accident, right? So that's also like a keyword, right? So now, as I said, like so now, like it with regards to our circuit, right? We won't be changing much of anything here, right? Because like it's sort of like similar condition. The what you call the signal is not retracted by another signal that's actuating the signal to go back, right? But instead being cut off by the stop signal, right? So now, if you look at our code, right, how I wrote our code, right, only one condition at this point, it has to be met for the signal to advance, right? So now we'll have to add another. So now, like to create an end condition, right? So that two conditions are met before the signal advances, we have to create like an end condition here, right? So end, it's this and this, like another like input, right, under the ledge of the output, right? So that will be an end console. So it's sort of like, if you remember, series connection, right? Yeah, in a series connection, right? For things to be connected, if things are connected in series, right? It's sort of like unless if either one of them they are not on, right? The circuit will not run, right? So input one and input two, they both need to be on for current to flow through, right? So now, like since they said we should use a limit switch to detect our positions, right? So now we'll define a limit switch, right? So now we have to first get our distance ruler, right? So we get our distance ruler here, right? And then we look for our limit switch, right? So this is our limit switch. So our limit switch, it's written changeover switch, right? And then now we add it as another input, right? So we'll add it to I3, right? And then if you connect it to this side, we're connecting it as normally open, right? Which is the mostly used method. If you connect it to this side, you are connecting it to be normally closed, right? Because current will flow to here through your connection into here, right? So like be mindful of that. Like always try and connect it this side, right? Unless like if you connect the other side, you have to always negate it because it will always normally close, right? But anyway, like I would prefer you to connect it like this, right? So now you label that limit switch, right? So if you go back to our ruler, right, want to define the limit switch like to be in the back end position, right? So like I'll just name this back position, which is at 0 and 0, right? And then now if it's at 0 and 0, right, which means as you can see now it's currently at the back end, right? And then now, like after we've added this, right, we'll also label our limit switch, right? So it's in the back position, right? So as you can see, since our limit switch now is currently in the back position, there's close because it's detecting that's at the back end position. You'll see when the senders advance, it's gonna open up, right? But now, like so now to fill the end condition, right? We come back here and then before we move on, we have to add another input, right? Our I3, right, which is at percentage sign ix 0.0 full. So we'll call this our limit switch, right? So as you can see, our limit switch is calling I3 because here it's connected to I3, right? So now if now like I have to fulfill the end condition, right? So I have to press the push button and it has to be in the back end position. So now this means I have to insert I3 here, right? And then label this I3, right? So now for the sender to advance, this and this, they both have to be fulfilled, right? That's only when the sender will advance, right? And then the power will be cut off by the stop push button, right? And make it to stop, right? So now if I were to oh wait. So now since I've also added in a new input, right? I have to build, select, and then build, right? And then now I log in with download, right? And then now I have to press play, right? And then so now you can see like okay, so my i3 is not turning on, so let me try and troubleshoot that one. Okay, yeah, I've just figured out what I did wrong. Like, so now since my i3 is 3 here, this has to be 3 here, right? And then I build, like, so, okay, and then I log in, right? So it's important to check these things every time, right? It's otherwise your circuit will not run, right? And then I press play. Uh, so now as you can see, since my sender is in the back end position, I3, which is our limit switch, it's on, right? So to fill the condition, I have to press this push button, and then these two conditions will be fulfilled, causing the cylinder to advance, right? So now my cylinder fully advances, right? And then it's gonna continue to advance due to the latch, right? So now that's my exercise number 2, right? And then now moving on, So this was the second, right? And then, so now moving on to exercise number 3, right? So the description of the problem is saying like pallet needs to be filled from a storage silo, right? So the silo is opened and closed with a flap, right? At which the process will be started at 2 locations, right? The silo will be started at 2 locations, right? And then they're saying the flap is opened by using either one of the 2 push buttons, right? And then and the bulk of the material is emptied out, right? When the stop push button is activated, the flap is closed as the cylinder retracts, right? So now, they're saying like we have to be like, so now we're designing a system, right, that can be used like to what you call, that can be controlled from 2 different locations, right? So you'll need 2 push buttons, right, that both like perform the same function, right? So they will cause the cylinder, they will both cause the cylinder to advance, right? They will both cause the cylinder to advance, and then the stop person causes the cylinder to retract, right? It will cause the cylinder to retract, right? So now, it means like now we need to what you call, we need to be able to control our, we need to be control our system like from 2 different locations, right? So now it means here we'll need to integrate another. So now we don't like need the scope back here. We need to integrate another push button here, right? So now how we integrate that push button, right, is that we come here, right? So okay, so now which means now we won't be needing our, stop push button, right? We won't be needing our what you call, sorry, it's not stop push button. One in this case, we won't be needing the limit switch, right? So you're just gonna remove this, right? And then now, as I said, we need another push button, right? That can be used to control the what you call the process, right? So now I'm gonna add. In this case, I'm gonna add a what you call. I'm gonna add this second push button here under I3, right? Which means now my I3 here, instead of it being the limit switch, now it's currently now the push button number 2, so it's PB2, right? Stop PB2, right? And then now I'll remove this as well, right? So now, like to ensure that our cylinder is able to be controlled like from different locations, So now to ensure that we are able to control our cylinder from two different locations, right? So now it means now we have to create an or condition, right? So I'm gonna explain it using circuits again, right? So now if you have what you call um let's double check something. Okay, yeah. So now if you still remember, if you have what you call an if you have a parallel connection, right? Both of the inputs, like yeah, both of the bulbs or resistors or whatever it may be, right? They don't both need to be on for the current to flow, right? So it means that like now, like for current to flow, right? Like it can flow in either direction, like it can flow in both, but it doesn't need both to be activated, right? It needs like either one, right? So if like let's say uh, let's check. Okay. Uh, Yes, this right. So as I said, like for current to flow like back to here, right? It doesn't need both of the what you call both this and this to be on, right? Either of them could be on, right? And then current, if this is on, current will flow through here and then back to the battery. If there's no power here, current will flow to here and then back into the battery, right? So current can be either flow on either way, right? So here we need to create something like that, right? So now since this is our I3, right, we need to make sure that like now either of these two patch pins, like they can activate the output, right? And how we do that is that we connect them in parallel, right? So in we connect all of them in parallel, right? And to ensure that the signal is also latched, right? We have the output in parallel. So now this will be our I3, right? And then we build, right? And then after we build, we now log in and then we log in with download and then we play. And then we also play here. And then now, now it can be used to advance the cylinder, right? And I can, in my mention stop to cut the power, right? And this push button be used to advance the cylinder, right? So now I'm able to control my pneumatic cylinder from two locations. So yeah, that's your exercise number 3, right? And then we'll do exercise number 4 and 5 in the next feed, right? So thank you guys for watching. Don't forget to subscribe and like. Sure.